We already discussed about the primitive data types: bool, character, int, float, and double. So today we discuss about derived data types, that is array, pointer, structure, and union. So why we call it derived? So they are derived. They are actually derived from the double or the float or the int or the character. So they derived from primitive. That's why they called derived data types. So let's understand how each and uh, every derived data types are derived from primitive data types. Okay, let's take the first example, array. So before diving into the array, first understand how this memory will be allocated for the primitive. Just say for example, for the character, when you say character A, when compiler come across this line character A, it identifies, okay, this is of type character, that means 1 byte, and the type A, so this is the memory name as int A, and it is 1 byte allocated. So this is the memory structure. Okay, so we identify this as random access memory. So this is a character A, 1 byte. So this is start with address 0, address 1, 2, 3, 4, 5, 6, like this. This is just an example. Like this will continue, or maybe after 6, this 7, 8, 9, 10, 11, 12. So this is the memory. Like this will go on. This 1 byte A. So this is 1 byte. Okay, this 1 byte will be allocated at address 0 to A. So this will be named as A. So whenever compiler come across the memory name A, so it will go and try to access address 0, whatever there in the address, the content will be accessed, or content will be written, or content will be read to A. Okay, so now character A will be allocated something like this. The 1 byte will be allocated at address 0. So this is what compiler will do whenever it come across character A. So this A will be whatever the content, this will be allocated at the, this is the content, this address will be 0. So whenever you say I want to read, say for example B is equal to A, you want to read A into the B, so it will go and read from the 0, whatever the content X, the content X will be read to the B. If you want to write something A is equal to B, so whenever you say this is a read, this is a write. So read means is reading from address 0, that is from A. The content whatever there in the 0, it will be read to the B. This is called read operation, and this is called write operation. So this B will be written to the A. A is addressed by 0. So this will be written into B. This is called write operation. This is called read operation. So this is a two operations we will do on the memory. Either we will write or we will write to the memory. So this is for the character A. That is how we will do read and write operation. So normally we do uh, two operations. Either we write or read from the memory. Now we go to the array. So this character is done. Now derived type of character, that is, we take array as example. Say for example character A of 5. So whenever you say character A of 5, it allocates 5 consecutive memory, and it will be named as A. Say for example 0 is already allocated in our previous example. Now from the 2 1, so this 5 consecutive memory, so 1 2 3 4 5. So these are the 5. This will be taken as A of 0 from here. Let's name it B. Let's not confuse with this A. So B of 0, this is B of 1, 2, 3, 0, 1, 2, 3, 4. 0 to 4. This will be allocated 0 to 4. That means 5 consecutive memory for the B. B of 0, B of 1, 2, 3, 4. So the character B is B of 5 is actually derived type of character. It allocates each byte for the each content of this 5. So B of 0 will be a 1 byte, like that for each index. So now how to do operation, the read operation. Whenever you want to read this B into A is equal to, we say B of 0. That means whatever there in the B of 0 will be read to the A. Like that we can change the index here to any number up to 4, 0 to 4. And one thing you need to consider here, for the C, the index normally start with 0, 1, 2, 3, 4, 0 to 4, not from 1. That you need to understand. That is a one major thing to understand about C. They start with 0, not with 1. Okay, 0 to 4 will be like B of 5 will be allocated. Now A is equal to B of 4 means the last address can be read, the content can be read to the A. This is a read operation. We can change index here from 0 to 4, and you can read all the elements into A. Now the write operation, how to write B of 0 is equal to A. That means A will be allocated and A will be stored here in the 0, like that. B of 1 is equal to B. Then B will be stored here. Like this, you can change index here up to 0 to 4 here, 0 to 4. Then you can allocate Z here. 0 to 4 means 4, B of 4 is this one, this memory, and Z will be written here. So this is the read operation, write operation derived from character. The consecutive memory will be allocated. So this is the derived type of array. Okay. Now let's understand one more type here. The character array is like you can store consecutive characters in a consecutive memory. Okay. Normally, say for example, if you want to save something like name or anything like alphanumeric information you want to store here, you can have consecutive um, memory allocated using this array, character array. Okay. Now character array is over. So now array of type integer. Integer C10. Here we just erase all our old content. Now C. Say for example, this is a RAM memory. We have all this memory available. This C will be allocated here at the 0, and 10 means 0 to 9. 0 to 9, all this up to here 0 to 5. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Up to 9 will be allocated. So address also same. Address also start with 0 and index also start with 0. So this 9 memory, 0 to 9, that means 10 memory will be allocated for integer. But one catch here, for each, based on, so we know that for the C, for this particular machine, what we are using, the width will be 4 byte. CPU width will be 4 byte. 4 bytes. That means each integer will take 4 bytes. That means 4 byte into 10 is equal to 40 byte required. So that means just for C of 0, just for one integer, we need 4 byte. C of 0 means 4 byte here. Then C of 1 here is this 2 byte, this 2 byte, this is 4 byte is required for C1, like this, and so on. C0 to C9. C0 will be 4 byte. C of 1 will be 4 byte. Like this, for each, total 40 byte is required to allocate C of 10. So the read and write remains same as we do for the character. So whenever you say say we have one more integer called b, so b is equal to C of 0. This is a read. Whenever it reads C of 0. That means these 4 bytes will be read to the b. And write operation, C of 0 is equal to 1, 2, 3, 4. This 1, 2, 3, 4, 1234 will be stored into C of 0, that is the address. C of 0 here, this 4 byte will be stored with 1, 2, 3, 4. This is the write operation. So that is how the integer array will work. This is the array that derived from this integer as an array. Okay, and now we then our next item, the pointer. We go to the pointer. We try to understand what is pointer.